So for exercise 3, I declare R8 as 2936FEDA. I add command ASR, which is the most significant bit at the left side will shift to the right for time. And RO will become 02936FED. For LSL, the left significant bit will shift to the left. R2 become 936FEDA 0. And for ROR, 4 places at the back will move to the front. Then R3 is, and the address R3 become A2936FED. Here for ASR, the most significant bit is 0 and move 4 times. We will come here, and then zeros, the most significant bit start here 0, 0, 1, 0, and so on. So the empty number that left behind will fill with 0. LSL will pick less significant bit and shift it to the right. So less significant bit will start at 1, and the places that left behind will fill with 0. So for shift to the right, the whole 4 places at the back will move to the front. So 1, 0, 1, 0 will become the most significant 16 bit here, and places left behind will fill with the last digit before that. So no places that will. In exercise 4, we need to OR function 6398 with 1 DFE. So I declare 6398 into address RO. Then I declare 1 DFE into R1, into address R1, and I use function ORR, which is OR function that will OR RO with R1 and save it into address R2. And R2 become 00007 FFE. For all function, 1 1 will become 1, 1 0 will become 1, 0 1 will become 1, and 0 0 will become 0. So there I have all the function. We must convert the hex number into the binary. So that is the answer for R2. Next, in this exercise, we are manually declare the memory in 4004 0000, which is 12 byte equally to 6 places. First declare R0 and declare R1. Next we move R2 12 as a counter. So the register will become C in this hexa number. For the looping, LDRB is used to copy the memory pointed by R0 into register R3. R3 will become 1 because first memory places inside 400400 is 1, and then I use post index to add 1 to address R0. R0 will become 40040001. For second line in loop, I use store byte, so the register in R3 is saved to the memory pointed by R1. As you can see, the memory 40040020 at first place will become 01. And then I also use post index to add 1 after the coding is executed. R1 will become 40040021, and I subs R2, then R2 become 000000000B, and this will loop until R2 eventually become 0 and trigger Z. Z will become 1 and BNE is, and the loop is over and the coding is done. As you can see, the memory inside 40040020 is 6 places equally to 12 byte, and the coding is done, and the CPSR Z equal to 1. For the last question, I declare R0 and R1. I also put num to equal 3 and move num to R2. So the register in R2 will become 00000003. Then I compare the R2 with 5. If the condition has met, which is R2 is greater than 5, it will jump to the store R2 square bracket R0, which is register in R2 saved in memory pointed by R0. In this case, however, the condition do not met, so it will execute the next line, which is add R2 0x60. R2 will become 00000063, and address in R2 is saved into the memory pointed by R1. Here at the first place at 40020010 it becomes 63, and next we will execute the branch next and straight to the end, so it will not execute the condition that if R2 is bigger than 5. So that's all for me. Thank you.